All right. So thanks for coming here to this conference. And again, it's always a pleasure to meet all of you. And so here today, I'm going to launch this BayesiaLab conference with a talk about Hellixia, our new baby, which is obviously connected with generative AI, so large language models. And I'm going to show you how we can use it for creating semantic networks and perhaps most importantly, causal Bayesian networks. So this is for obviously the Bayesian network, for knowledge discovery and decision support. But before that, so as Stefan mentioned, so for those who don't know me, I'm Lionel, as the CEO of Bayesia. And this is a company we have created in 2001, so it starts to, yes, 23 years ago now. And so we are based in France, northwest of France, so near Brittany. We have Bayesia in the US since 2012, and then with Stefan, and in Singapore since 2012. And here I'm just using this old-fashioned slide just to describe some of our customers, and it's just to show you the range of applications. So the utilization of Bayesian network is not just focused on one type of application, even though we have lots of application in market research, but it's really used in the field of energy, in the field of risk, as you can see, bank and so on and so forth. And here I just also want to say a special word about P&G, our main customer. And this is also one of the reasons why we are in Cincinnati here with this very nice weather. So thanks you for this, for having organized this weather. And here, so now I want to switch to a much more modern version to present our customer is by using semantic network. Right. So what I did, I have selected my Excel file where I have all my customers. I've done a filter to keep only those with a certain amount of turnover with us. And so here, each node, each bubble here represents one customer. So you have 350 or so here. And the size of the node depends on the turnover they have with us. Right. And the connections have been automatically learned by using embeddings. So I don't know if you are familiar with that. So the idea is just I loaded the name in BayesiaLab. So just a file with 3 rows. The first row, the name of the company. Second row, 0. Third row, the turnover. So this allows me to create automatically these 350 nodes. And then I'm creating embeddings for each of these companies. So an embedding, this is this vector here that you see. So this is the very first step of LLM. And I think this is really a very, very smart step. So because, when you, as a computer scientist, if you have to represent a name, or I would say that even 10 years ago, what you would do is just create a lookup table and have 30,000 entries and just have the ID of the name. But with that, you cannot do anything. So now the step is to, instead of having this basic way to code the name, they are using just a very shallow neural network with one input layer that contains 30,000 tokens, the output layer 30,000 tokens, and you have the hidden layer that contains like kind of latent variable if you want. And so this is just to learn. So they are using this neural network to try to predict when I see this token, what are the tokens that I can find before and after. So by using billions of documents, so they are learning that, for example, when you see the token car, so chances are going to see road, accident, bus, plane, perhaps something like that. So which means that now we are not only describing car with an ID, but with 1,536 numbers here that represent 536 latent variable concepts, right? So this way, car is going to be close to bus, close to plane, but far from baguette, right? So the French bread. Okay. So this is what we call embeddings. So I've created embeddings for P&G, Unilever, Mondelez, and so on. So just by using this name, so by analyzing these billions of documents, it knows that P&G is close to Unilever, which is close to L'Oreal, which is close to Cosmetic Europe, right? So without saying anything, so I'm just learning that. So I have this vector for each node, and I can machine learn the relationship between the nodes. So this means that this is purely semantic, right? So the connection you have are correlation, right? So this, and you can see John, you are here. and there is also John Oliver John, so who is not there today. So you are connected because there is a John here. You are not known enough, famous enough, right? And you are close to Cargill. Who knows? Do you have some share in Cargill? No. Okay. And here you see, so this is another area where our software is used, or another one, so the one we use for troubleshooting. So you have all these bubbles that represent, you know, the Airbus helicopter, Safran helicopter engine, Safran aircraft engine, so all this technical stuff here. And this is connected with Airbus, and then Lockheed Martin, and then NASA, and then the National Aerospace Laboratory. And as you can see, we have also Mars, which is connected to Lockheed Martin. But Mars here, this is a pet food company. So, but just by using embeddings, it does not know if it's a company or a planet. And we have the same thing here with, so this is SNCF, this is a French railway companies. And we have Metro that is connected with RATP, but Metro is also the distribution company. So obviously, it's not 100% perfect. But still, it's quite impressive. So you have all the consulting companies here. You have Microsoft, Facebook, eBay, Micron. And then you go down, you have all the market research customers. And then after that, you have the universities, the most important university we are working with here that are clustered by using the country more or less, right? So this is now, I think, a much interesting way to present customers than just by using the logo, and we can even plug the logo on the node, obviously. So now let me use this old slides too, but it's still convenient to present the workflow of BayesiaLab. So, you know, Bayesian networks are one of the main pillars of AI, even though now everybody is talking about LLM, but it's just one pillar in the AI field. And so here for us, the brain of our expert is always a Bayesian network, right? This thing. So, and we have various ways to build this network. Right? So first one, so historically, it was only possible to build a Bayesian network by hand. So you were alone and creating your nodes, defining your probabilities. So this was in the 80s, right? Then what we do now a lot is, instead of having only one expert, we do brainstorming session with 15, 20 experts to create network by using their expert knowledge. So this is something we do more and more. The other way to create Bayesian network is indeed the reason why we created Bayesia 23 years ago is to use machine learning algorithms. So you have data, you analyze the data, and you create your network, right? Obviously, there is a way to mix both approaches, right? And since last year, we have the third way by using Hellixia, right? And again, now the three can be combined. So you can start by brainstorming session. During the brainstorming session, you can use Hellixia. You can use Hellixia for machine learning. You can use machine learning for updating the network you have done by brainstorming session. Everything is intermixed now. And once you have your network, then you can use it for decision support, right? So diagnosis, optimization, simulation, risk management, and so on. So today, I want to talk about my new baby, Hellixia, here. So in case you ask where the name is coming from, so I use ChatGPT for finding the name, so obviously, right? And the logo too. So Hellixia here can be used for creating semantic networks, right? So again, not really Bayesian network. We are using Bayesian network for representing semantic network, so it's a subclass, if you will. We are using Hellixia for creating comments, associating comments with our nodes. We are also using it for naming groups of nodes. So when you create clusters of variables, so it's a very useful tool for finding the name that describes this group of nodes. We are using it for semantic variable clustering, even though we still prefer to use our variable clustering algorithm for that, but this is an option. We are using it for creating textual report. You know, when you have the analysis of your network, you can generate a text report that will take into account the most important dimension in your network. And one of the most important things is there is four causal analysis, which is one of the most difficult parts when you do Bayesian networks. Creating images, this is not that important, but it's nice to have feature, right? And another nice to have feature is translation, right? So for you, if you are always speaking English, it's not a problem, but when you are switching between languages, it's very, very important, right? So Hellixia, at the end of the day, is what we call our subject matter assistant, right? So this is the best employee in Bayesian now since 2 years. She's working with me every day, 24 hours a day almost. And now I want to start by talking about semantic network, because this is always the first step when I do some analysis now. And I just created this image yesterday evening. I had this, because for me, a semantic network is a way to send sensors to a domain that I don't know. Because since we are doing lots of brainstorming sessions, so it can be for diapers, it can be for polymer, it can be for toothpaste, it can be for anything. And each time I'm starting a brainstorming session, I don't know the domain, so I'm now using my semantic network to send sensors in this domain and capture the relationship between the dimensions. So this is my prompt from yesterday evening: create an image that represents the idea of sending a sensor in an unknown domain. So this is the result with DALL-E 3, which is, I think, I like it. So the semantic networks are, as I said, are Bayesian network in which the relationship are not causal, but just represent a correlation between the semantic associated with the nodes. They are mostly qualitative, which means that we are not using them for doing any probabilistic inference, right? So I say mostly because we still have the size of the nodes that capture some kind of quantitative dimension. And so they allow you to have a very efficient understanding of a new domain, right? So because this is really very efficient for gathering what are the most important idea of the field. So this one is an example of a semantic network that I've designed 2 or 3 weeks ago during the last webinar I did on the delay in scheduled flight departure. So even though this is not an unknown domain, but in 5 minutes you can create this kind of network where you just ask this question, and then you have, so you can see that, well, delay can be due to weather, weather condition, can be due to fueling, can be due to boarding delays, catering problem, passengers, baggage handling, cargo operation, airport operation, the ground operation, and then you have the crew, you have also the maintenance of the aircraft, the technical problem, you have the bird strike, and you have all these regulatory issues and so on. So very quickly, you have the most important dimension of this problem. And when you see that, perhaps say, oh yes, it's obvious, but when you start, usually it's not that obvious, right? So creating this kind of network, even by using brainstorming with experts, will take you at least 4 or 5 hours just to get all these dimensions, right? So now I want to show you how we build these semantic networks. And I'm using something that perhaps there is only Emmanuel that is aware of. This is a corporate sustainability reporting directive that is becoming mandatory in Europe. And so this is a domain that I was absolutely not an expert in a few days ago. So I just have this video here. So I'm using the last version of BayesiaLab, 11.3, that was released on Friday, just before my departure. And so we are sorry, there is a bug inside it. So we need to release 11.3.1 soon. So here, this is a classical startup page. And so when I want to create a semantic network, I just create a node where here I say this is going to be the topic of my query. This is a corporate sustainability reporting directive. So I create this node, and then I go to the Hellixia menu, right? So you see that we have all these options. So every topic I mentioned in the previous slide, so you have the dimension elicitor, the embedding generator, so for creating these vectors, you have all the causal features and image and translation. So here, I'm gonna select the dimension elicitor, and you have this wizard here where I have pre-selected 157 keywords. So these are the keywords we are using in our internal prompt in order to send the sensor in this domain, right? So, for example, I can ask for what are the competitors, what are the concepts, the ideas, the pros, the cons, and things like that. I have here on the right the groups. So this is when you are using a set of keywords on a regular basis. So instead of each time selecting them, you can memorize your group of keywords. So here in this example, I'm gonna just use definitions. So I want to have the most important definition associated with this domain. Then you have below, you can specify if you want to have a specific number of answers or not. So here I selected this, 10. And here you have the list of the engines that you can use. So at the very beginning, obviously, it was just GPT 3.5. Now it's 4. We have also, since a few weeks, Mistral. So I don't know if you know Mistral. This is a French company that is really competing now with OpenAI, even though GPT 4 is still slightly better for causal analysis, but it's good. And it's faster. Then you can also have your own GPT assistant. So I don't know if you are familiar with this, but the one you can really, dedicate to your specific domain by uploading document before. And then, so you select your engine. You can also define a knowledge file. You can define the context of your study, define the topic, the main subject of the query, and then the language, right? So here I'm selecting English. You can set the description length, and you submit the query. So this is now connected with the API. And real quick, you're gonna have the dimensions. So here, by using GPT-4 Turbo, I have the 10 most important dimensions associated with the CSRD question, right? So scope, reporting standard, frequency, comparability, and so on and so forth. So you have the name of the dimension that we're gonna use for the name of the node, and also a description of this dimension, right? So after that, I'm gonna say, okay, this is mainly a European question, so perhaps using Mistral is gonna be better. So on top of that, I'm also using Mistral, and then I have 10 additional answers, right? And then I said, well, I can also define my own GPT assistant. So I created an assistant by using OpenAI. I went to the European website, European Commission website. I took 2 PDF with like 100 pages, uploading them in my GPT, and created a GPT assistant that is a specialist of CSRD, right? And then I'm using it as a new engine. And then I can have 10 additional nodes that are gonna be more specific. And as you can see, there is one here that is not taken into account because it was already defined by another one. So we are not taking into account the nodes that have the exact same name, right? So what is this? All right, so I just want to, yeah, so let me go back. So this is a problem with these videos, is like, as soon as you have them, you touch something, come on. Well, anyway, bear with me. Accelerating a little bit. So once you have done that, so I have more or less 29 nodes, if I remember correctly. So this will create automatically my 29 nodes. So I'm starting with one node, and after a few minutes, I have 39 nodes that describe the domain. Okay. So you have a second chance to follow the steps. And the last one, CSRD. Good. All right. Okay. So now this is creating the nodes. And I'm just excluding now my query node because I don't need it anymore. And so the next step is, because right now what I have nodes with only two states, true, false. I don't have any data, so I cannot do anything with that. So I'm gonna use my Hellixia embedding generator for creating the vectors that I will then be able to use for machine learning, right? So that will capture the embeddings, the semantics, I mean. And here, same thing. Since a few weeks now, we have different options, because before it was just ADA 2. Now we have OpenAI release also the ADA large and small, and so which are better. And also we have the possibility to use the embeddings coming from Mistral, which are really good. So this one, the large one, now it's a vector of 3,000 plus input, and Mistral is just 1,024. So now I have a data set of 3,000 rows. And what I can do since a week or two, I can use both. So I can also use Mistral on top of OpenAI, and I'm just creating a database of 4,000 rows. So this way, I'm merging the two embeddings and have something much more interesting. So then once I have that, I have a data set with 4,000 rows. We are automatically discretizing these variables into 5 bins of equal frequency, because there are absolutely no meaning. These are just the activation level of the neuron. So we cannot interpret that. What we can use is the relationship with the other nodes, but there is no direct interpretation. And then I can use our classical machine learning algorithm. So I'm going to go here, use a maximum spanning tree, and then discover the most important relationship between these dimensions, right? So a little bit of layout. And then you have the network that represent the connection between the 29 dimensions that describe this domain. I can then use variable clustering, because here there is a step that I'm not doing, but when you have to do a real study, since it's an assistant, you have to clean a little bit because there are some redundancy. But here I don't even spend time on that. And I'm using data clustering, variable clustering, to, if I have redundancies, then the cluster variable will capture that automatically, right? So here I also want to show you a new feature that here you can click on generate cluster with names. So this will automatically use OpenAI or the engine you are choosing for creating the name of the factors. So instead of having just factor 0, 1, 2, 3, 4, you're going to have a useful name. So here I'm using Mistral for that. And then use settings here with a short description length. I have one color per cluster. So here he created 5 clusters of variables. So here this is a dendrogram. And when I'm hovering over the point in the dendrogram, I have a name that has been created by the LLM, right? So this is a summary of these 2 nodes here. This one for the financial and non-financial dimension. So you have all the names have been automatically created. So which means that now when you go to the mapping, instead of having factor 0 or the name of the strongest name of the cluster, it was before, you have something that makes sense, that summarize your cluster. And so when you hover over the bubble, you have the list of the nodes that are associated with them, right? So you see all these names have been automatically created. Double materiality, and here you see we have some redundancy here. So you can then decide what is the best number of cluster if you don't want to use the default value. Right? So here these are the non-financial statements. And now, so I'm validating this solution. I have my classes that are automatically created, and then I have a description with the name that comes from the LLM. And then I go to the class editor. You can see that I still have here the description. And I'm going to use now or implement the probabilistic structural equation model approach, right? First, I'm starting with the node force, just to have an idea. So here, this is the force of the nodes, but based on the semantics again. Just keep that in mind. So with the non-financial statements, the reporting standard, the double materiality, the social responsibility, the comparability, and so on. Right? So let me accelerate a little bit this. Then, so as I said, I'm gonna just go to my PSEM feature. Right? So once I have these clusters of nodes, the idea is to use multiple clustering to create a hidden variable that will represent this concept. So I'm using the usual options here. And then, so use 5 states at the end of the day. And this will create like a kind of embedding that comes from BayesiaLab, because this is a variable that will summarize embeddings. So you can also interpret it as embeddings. And here, so I'm gonna just finally learn the probabilistic structural equation model. So just learn the relationship between the hidden node here. And so this is my hierarchical Bayesian network, where I have, so the first layer are the nodes that comes directly from the LLM, right? And then this one, so I have a second layer with my concept, with the name that has been automatically generated. So here you have then a representation of this domain with a hierarchical Bayesian network. And just to show you that it's really a hierarchical Bayesian network, so you can use the 3D mapping, and you can clearly see that you have 2 levels, the levels of the manifest and the level of the factors, right? So this is a hierarchical semantic network, if you will, okay? So let me continue with still the same domain, the corporate sustainability reporting directive. But now, instead of just trying to find what are the most interesting dimensions in this domain, I want to understand why we have this corporate sustainability reporting directive. So I'm going to create a causal Bayesian network that will give me some explanation, right? So this is more or less the same thing. I'm starting with just the node, CSRD, and then I'm choosing the GPT-4 Turbo because this is really for causal analysis. I think this is the best one. So then, so here it takes 2 minutes for that, but it's a little bit accelerated. And then I have this network that has been created. And this is absolutely not the same thing as the other one. Here, I don't have any embeddings. I don't have any data, right? And my nodes are Boolean, so we are just using proposition, right? Because we don't have lots of options here because we don't know anything. So we have proposition, and this is a fully specified Bayesian network. So by that, I mean that I have the structure, the causal structure that has been given by GPT-4. I have, so my original question is in the middle, the CSRD, and I have the explanation. So when you have a blue arc, this means that this is a positive contribution, red arc, negative contribution, and you have the width of the links that gives you the strength of the connection. So that goes from -100 to 100. And thanks to this coefficient, I can automatically populate the conditional probability distribution, right? So I'm not saying that this is perfect and then you can go, but at least you have a kind of toy. You can already do inference with that and analyze really what GPT-4 has in mind, if he has a mind, right? So now, so you see the explanation for this directive. This is coming from first the technological advancements, then the EU legislative process that is itself defined by the NGO influence, the international agreements, the economic climate, the corporate lobbying, and the investor demands of transparency, right? So you have these explanation, and then you have also all the consequential variables here with the policy effectiveness. If you have this, if you are following this directive, then you are going to have some sustainability practices, investor decisions, so, and you have the name of the node, and again, the description of the dimension. And you also have a description of the relationship on the links, right? So a new feature that we have introduced a few weeks ago too is the possibility to move the comments associated with your links, right? So which is, since we are using more and more comments on the link, it's mandatory. And we are still working on an algorithm that will lay out that automatically. So now, as I said, my nodes are Boolean. And so when I have a root node, by default, I'm assuming that this is either a risk or an opportunity, but it's not that frequent. So I start with 99. So it's 99% false, 1% true. And when I have a node with parents, so we have created a new formula that allows us to take into account positive and negative influence. So this is what we call the dual noisier. And so I have a leak, and then I can take into account positive influence, negative influence, mixing everything to create automatically this conditional probability distribution, right? So this is here an example, right? So now, since I have, so what I'm doing, because all these nodes have the exact same color, so I don't like that. So I'm creating classes based on the depth in the network, and then associate colors based on the depth. So, which means that the root nodes have the same color, and when you go down, you have different colors, right? And then I can use this network for in analysis, for really in validation mode. And here, generate a report that analyzes the strength of the relationship, right? So this is the usual analysis, but so it's really like you send a prompt to ChatGPT, but you don't just have a text that you probably will not read. Here, you have a structuration of the knowledge and a quantification, right? And then based on the analysis of the Kullback-Leibler divergences and so on, that are taking into account the coefficients that have been given, you create this report, and I'm going to be able to use my report analyzer here just to have a kind of summary of this report that is just based on figures here. So I'm just defining here the context. You again choose your engine, and then you have a report that is generated here that say, okay, so here is a domain that you are analyzing. And so he's analyzing not only the node force, but also the arc force. So node force are the main dimension in your domain. Arc force has the strongest relationship in this domain. So then you have the summary of that. So it's another way to, because usually customers ask for what do you extract from these tables. You can have a first idea, right? And based on that, you can create a note. So you can automatically create a sticky note of this report, and this way you can have this note associated with your graph directly, right? And now, the idea is to, I'm a lot in philosophy, you're going to see that in a few minutes. But, and so if you know Hobbes, the definition of curiosity for Hobbes is the knowledge of causes. So here you start with, you don't have any knowledge, then you start to find the causes of an effect. And once you have this, you start to find the cause of the cause and so on and so forth, till reaching God, right, probably. And so here I have the causes of CSRD. Then I know that this is based on European legislation process. And I see the one node that is a corporate lobbying. So I say, okay, what explains this lobbying? So I do the same thing. I create another causal network on top of this one. So they are going to be mixed. And here now I can specify the context. And then, so this is not an easy process, but you have a second network that will give you more information on this. And so you can imagine that you can do the causal, or the causes of the causes of the causes of the causes, and see where you're going to arrive, right? So same thing, I'm removing these classes and then defining the depth. And I have now a much more comprehensive network that explains not only why we have this CSRD, but also what are the drivers of the corporate lobbying, right? And now what I'm doing is I'm setting cost to the non-root nodes, so just to say that they are not going to be observable. So I just want to take into account the root nodes, and I'm analyzing the strengths or the correlation with my target nodes. I want to know among all these root nodes, what are the most important ones given this network. So you have the sorted list of drivers if you want. And then, so you see that I can really play with my network. I set evidence, and then I have the impact on my target. And at the end of the day, I can use all the analytical tools that are available in BayesiaLab. And just for Dave, here you have your famous tornado graph, right? So you see that what are the most important dimensions that explain this directive, okay? So are you ready for a switch? We are gonna focus now on something much more interesting.
Before you switch, can we have a question?
No. I want to switch now, but at the end, yeah, okay? Because this is a really important moment now. Can we close the door, shut down the lights? So we are going to see now how we can use this subject matter assistant for analyzing deep things, right? So I'm in love with Shakespeare, and I'm going to use Hellixia for creating a causal network that will explain the soliloquy that you know. So, and I'm going to go.
To be or not to be, that is the question. Whether 'tis nobler in the mind to suffer the slings and arrows of outrageous fortune, or to take arms against a sea of troubles, and by opposing end them. To die, to sleep no more, and by a sleep to say we end the heartache and the 1,000 natural shocks that flesh is heir to. 'Tis a consummation devoutly to be wished, to die, to sleep. To sleep, perchance to dream, aye, there's the rub. For in that sleep of death, what dreams may come when we have shuffled off this mortal coil must give us pause. There's the respect that makes calamity of so long life. For who would bear the whips and scorns of time, the oppressor's wrong, the proud man's contumely, the pangs of despised love, the law's delay, the insolence of office, and the spurns that patient merit of the unworthy takes, when he himself might his own quietus make with a bare bodkin? Who would fardels bear to grunt and sweat under a weary life? But that the dread of something after death, the undiscovered country from whose bourne no traveller returns, puzzles the will, and makes us rather bear those ills we have than fly to others we know not of. Thus conscience does make cowards of us all, and thus the native hue of resolution is sicklied o'er with a pale cast of thought. In enterprises of great pitch and moment, with this regard, their currents turn awry and lose the name of action.
Poetry. I hope so. You with the echo is not that bad either. It gives you the the ambience. So this was this is coming from poetryspoken.com, and so I just found that yesterday evening because was it okay? Because otherwise I know that you don't have the time to read. So Stefan will say, "Oh, there is some typo." No typo. This is archaic English, and so I don't know if you probably knew this to be or not to be, but perhaps just there. But after that, you have all this nice talk, and so the idea is, where is that? So we use here the causal network generator for analyzing this soliloquy, and here is the result. So you see that there is a desire for an end, the nobility of the spirit, the paralysis by analysis. Then you have the post-mortem dreams, the fear of the unknown. So you have all the explanation of the main ideas that are in this soliloquy. And I think it's really cool. No, I don't know if you share this thing, but this is really for really understanding things that are really deep. You have this tool that allows you to extract the most important dimension. Right? So this is one way to do some kind of text mining at the end of the day, something that was not available in BayesiaLab because BayesiaLab was only able to analyze some structured data. So here now, we can really start without anything with a text and anything like that. And I'm going to conclude on something more serious, a little bit of Kant with the critique of the pure reason. And here I'm going to also generate a causal Bayesian network on the text, but also try to find some explanation for concept. So this is the excerpt of the critique of pure reason that I've taken here about theology. And so I did not find any actor to talk about that, but anyway, so I let you read that. It's not that long. So I'm using Hellixia for going through this text and then analyze, create the causal Bayesian networks that correspond to this text. So you have this excerpt, and as you can see, he found that indeed theology can be either rational or revealed. So you have the two rational in green, revealed in pink, right? Then if we go up, we're going to have an explanation of the transcendental theology that is depending on pure reason and transcendental concepts. And then an explanation of the natural theology, the nature of our soul, and concepts that are derived from nature. So you have these three sources for thinking, for the theology, right? And you can see, so I have highlighted a portion of the text, so everything has been nicely captured, right? And then there is something here, I don't know if you know Latin, I don't. So I can also say, oh, what if I want to understand that? So this is the ens originarium realitium ens entium. You speak Latin? Yeah, that's correct. So here, same thing. I create a node with just this in Latin, and then you have this causal Bayesian network that explain this, this expression. And then, so it's not only now the critique of pure reason, but you have also the critique of practical reason. And then you see with the freedom that is connected to the categorical imperative, that is connected to morality. Then, so this is fitting in this ens originarium. You have the sublime part that comes from beautiful. And then you have the famous concept of Kant with the noumen and the phenomenon. So you have the noumenon and phenomenon that are driven by the concept of understanding and so on and so forth. I'm not going to spend time on that. But this is, everything here is super deep, right? So, and this is, in a few minutes, you can ask for the analysis of these very, very deep concepts. So this was my philosophical and poetry parenthesis in this talk. And you have, otherwise, on the website, you have lots of examples because, again, as I said, I'm using that every day for everything. So there are lots of examples here for literature, music, what have you. So you can really ask any question and then create network that explain the domain. So you're going to find lots of these here. I have done a causal Bayesian network on atopic dermatitis, so eczema. And I'm not a dermatologist, but I'm working with dermatologists, and they had a look at the network and say, that's good, it's perfect. So you very quickly, in 5-10 minutes, you create networks that are very, very useful. Here, this is the one I use during a few minutes with a schedule of delay in schedule flight departure. And thank you for having listened.